The topic of today's topic is hand instruments in endodontics. The primary goal of root canal instruments are to provide a biological environment that is conducive to healing and to shape the canal which is comfortable for sealing. Starting from the history, in late 1746, one of the first instruments made specifically for use within the root canal by Faucher. In 1858, Maynard advocated a pulp removal instrument called the barb broach. After later, 1852, Dr. Robert Author described how to make a fine pulp space file and provide a guideline for the mechanical properties. In 1950, Kerr Manufacturing Company patented all the K files and instruments. Late in 1958, Engel and Levin first proposed the standardization of endodontic instruments. In early 1980s, K-style endodontic instrument came into the series of modification with hybrid designs. In 1988, an Indian author, that is the Walia et al., the first reported the use of Nita instrument alloy for endodontic use. In 1992, Herbert Schilders, who instruments with the constant taper of 29.17% increase in this pipe. In 1997, a Tri-Auto ZX, which is a cordless engine-driven pulse space preparation system, was introduced by J. Morita, Japan. Coming over to the classification of the instruments, according to the Grossman, it was subclassified based on the exploring instruments, which used to locate the canal orifice and determine the root patency, canal patency, like the endodontic explorer. Others were the debriding instrument to extirpate the pulp and remove any foreign bodies, like barb broach. The cleaning and the shaping instrument, which used to clean the canals laterally and the apically, with the help of, for example, the reamers and the endodontic files. And last comes the obturating instruments, which are used to pack the GP into the root canal like spreaders, pluggers, and lentillar spirals to coat the root canal sealers. And another classification by ISO or FDI system, which subclassified based on the group 1, that is manually operated instrument like K files, H files, hand operated. Group 2 are the low speed instruments with a latch type attachments like GG drills or the gate grid and drills or piezo reamers. Group 3 are the engine driver rotary night type files like night type rotaper rotary files with the continuous rotation. Group 4 are the engine driven instruments which are self-adjustable like self-adjustable file. Group 5 are again the engine driven with the reciprocation instrument, that is the wave 1 and reciprocation rotary night type files. And group 6 are the ultrasonic instruments. The clinical classification includes the instruments which are used for diagnosis, like the endodontic explorer to explore the floor of the pulp chamber, tooth slot to check for the vertical fracture, the dental transilluminators which are checked for the secondary caries or the proximal caries, the pulp vitality tester to test the vitality of the pulp. Next are the instruments used for the canal preparation, which used to remove the pulp tissue like barb broach or the endodontics excavators, or the others are the root canal preparations like reamers and files. The instruments used for root canal obturation include the lentillar spirals to coat the sealer on the root canal walls, spreaders to laterally compact the GP and create a space for the successive GP, the pluggers and the condensers to compact the GP apically and laterally while obturation, heat carriers to soften or melt the GP within the canal, and the thermomechanical compactors. Coming over to the standardization of endodontic instrument, which was given by Engel and Levin, it says that the instrument shall number from 10 to 100, which are the numbers. The number denotes the apical size of at the tip, that is the D0. These number advance by 5 units till the size 60 and then by the 10 units. For example, it's 10, 15, 20, 25. And it has been revised to include the number 6 and 8 in the sequence till the 140. Each number shall be representative of the diameter of the instrument in hundreds of its millimeter at tip. For example, for a number 10K file is 10 divided by 100 is 0.1 mm, that is 0.1 mm at the D1, that is the tip diameter. Similarly, number 25K file is 25 by 100 or 0.25 mm at the tip. These are the diagram which shows the D1, D2 and the D16, which is a diameter or the length of the file at the 16 mm. So the working blade or the flute shall begin at the tip, that is D0, and shall extend till D16 mm, that is D16. So the diameter at D16, 16 mm length, shall be 32 by 100, that is 0.32 mm, and the greater than that of the D0. For example, number 20 reamer shall have a diameter of 0.20 at D0 and diameter that is 0.20 plus the 0.32 mm. So that it will be 0.52 at D16. The sizing ensure a constant increase of taper of 2%. In case the file is 2% taper, there will be the increment of 0.02 mm at each flute, at each mm. There are the further specifications which were added later to this standardization, which includes the tip angle of instrument, which is should be 75 degree plus minus of 15 degree. The instrument size should increase by 0.05 mm at D0 between 10 to 16. Example number 10, 15, 20, 25 and so on. And they increase by 0.1 mm from number 60 to 150. That is, after number 60 file, it will be 70, 80 and so on. The other specification was added number 6 and 8K files like 0.06 and 0.08 mm files, which were added in the instrument section. In addition, the instrument handles also have been color coded for easy replication, easy remembrance of the instrument. Here are the ISO color coding, which includes the pink or purple for newly added instrument, which were 6 and 8, and after that 10 number file of purple color, then white, yellow, red, blue, green and black, corresponding the 15, 20, 25, 30, 35 and 40 number file. Coming over to the metallurgy of instrument, these are, first of all, previously it was composed of, it was manufactured with carbon steel material, which comes with few advantages of higher hardness than the stainless steel, but have few disadvantages like prone to corrosion and cannot be autoclaved and was prone to rust. Later comes the stainless steel instrument with the advantages of corrosion resistance, but the disadvantage was it was stiff in nature, prone to fracture and prone to distortion. Later comes the nickel titanium instruments with the advantages of shape memory, the super elasticity, low modulus of elasticity, corrosion resistance, softer than the steel, good resiliency, biocompatibility, and the other disadvantages like poor cutting efficiency, and it does not show the signs of fracture or the deformations. Coming over to its manufacturing, the hand-operated instruments, reamer or file begins as a round wire modified to form a tapered instrument with cutting edges. These are manufactured by two techniques, machining and grinding and twisting. In machining, the instrument is directly machined on the lathe, for example, H-file or NITA instruments, and in grinding and twisting, a raw wire is grounded into tapered geometrical blanks, that is the square, triangular or rhomboid. The blanks are twisted counterclockwise to produce the cutting edges. Talking about the components of the endodontic file, the taper. The taper, it is expressed as the amount of the file diameter which increases each millimeter along its working surface from tip towards the file handle. The greater the taper instrument have been developed with the 4%, 6%, 8% and even 10% taper. Tapered instrument help in preparing the canal of wider diameter without over enlarging the canal at the working length. See, this is a table which shows that number 35 of 2% taper, even of 2%, 6% or 4% taper, every file will have a same diameter at the working length, full working length, that is D0, that is 0.30 mm, whereas 1 mm above, that is D1. The 2% file will have 0.32 mm diameter, 4% will have 0.34, that is a jump of 0.04 mm in 4% taper. Whereas in 6% taper, D0 it will be 0.30, but at D1 it will be 0.36 mm. So the taper of 6%. But all the file of different taper, they will have a same apical or the D0 diameter of file 30 if we consider a 35. Similarly, at 2 mm and the 3 mm above the tip, that is D2 and D3. Next comes the core. Core is the integral part of a file which provides the strength to the material or to the file. It is a cylindrical part of a file having a circumference outlined and bordered by the depth of the fluids. Significance is it provides the flexibility and resistance to torsion. See, if the core is wider or stronger, the fracture resistance will be more, but at the same time the flexibility will be less, and the fluids which has been present over it, the depth of the fluid will describe the type of the cutting or the grinding motion. Next come the fluids. Fluid, it is the groove or the relief in the working surface used to collect the soft tissue and dentin chips removed from the wall of the canal. The effectiveness of the fluid depends on its depth, how deep it is. It will tell about the cut made by the files. The width of the fluid will describe the strength of it, and the configuration and the surface finish of the fluid. Next comes the cutting edge, the surface with the greater diameter that follows the groove where the fluid and land intersects. As it rotates, it forms the leading or the cutting edges or the blade of the file. Next comes the length or the marginal width, which is an important aspect of an instrument. It is the surface that projects axially from the central axis as far as the cutting edge between the fluids. Its function includes it prevents the screwing of the file. See, if the file or the fluid of the file is sharp, deep or wide in its configuration, it might screw, but if the land area is more, the screwing will be prevented, as well as it will provide a space to collect the dentinal debris which has been chipped off during the canal preparation. It supports the cutting edges and reduce the canal transportation. If the screwing has been prevented, then the transportation will itself is secured. Limits the depth of the cut, and it maintains the file in the center of the root canal. These are the land areas of the two different files. The first one has a smaller radial length which is equals decrease the strength of the blade support, whereas in the second one there is a larger land area, increase the radial length and increase peripheral strength behind the cutting blades. Next comes the helix angle. The angle formed by the cutting edge with the long axis of the file, it helps in removing the debris collected in the fluid from the canal. The next is the pitch. Pitch of the file is the distance between a point on the leading edges and the corresponding point on the adjacent leading edge. It may be the distance between the corresponding fluids, that how much there is a difference between the two fluids. If the two fluids are too closely present, then the cutting efficiency is less. It is more of a grinding or the reaming motion. But if there is a distance between them, it is as a more cutting motion. Along with the depth of the fluid also plays a role. Next comes the rake angle. It is an angle formed by the cutting edge and the radius of the file when the file is sectioned perpendicularly to its longer axis. If the angle formed by the leading edge and the surface to be cut is acute, the rake angle is said to be negative or the scraping angle. There will be more cutting if the rake angle is negative. It will more scrape, cut, and if it is severely negative, it might dig the canal walls also. The most conventional endodontic files utilize a negative or substantially a neutral rake angle so that the cutting remains there but not the digging action. And the other reaming files which don't have a cutting function, they have a positive rake angle. If the angle formed by the leading edge and the surface to be cut is obtuse, the rake angle is positive. Positive angle has a more efficiently in the neutral rake angle, like the H files and the second generation rotary files. The over positive rake angle will result in the digging and the gouging of the dentin. The other design is the tip design. It can affect the file control, efficiency and its outcome. It could be a cutting tip or a non-cutting tip, which is used according to the selected according to the case. The tip of the original K file resembles a pyramid shape. Instruments have been described as a cutting, non-cutting, partly cutting, although no clear distinction exists amongst these three types. but the cutting do describes and decide according to the case. The finer the size, the resistant to torque will be there. The larger the size, the more resistant to the torque will be there. Now talking about the hand operating instruments in the endodontics. First comes the bar broach, which is used to extirpate the entire pulp and for the removal of necrotic debris, any foreign particles or the absorbent point or material stuck into the root canal. It is prepared by either the taper instrument prepared by soft steel and the notches made over it and extending outwards from the shaft. This design itself makes it a very frequent to breakage and less resistant to fracture. It is available in different size from triple extra fine to extra coarse. But due to its least fracture resistance, it has now been obsolete and not used nowadays. Next is the rasp. There is a difference between a broach and the rasp. That is the difference of only the notching, the depth of the rasp, the flutes which has been used. The barbs extends to half of its core diameter, making it a weaker instrument, whereas in it rasp, the barbs are extended to 1/3 of the core, so it is not as weak as the broach. Next is the reamer. It is an instrument that ream, that is the not the cutting. It is the reaming action and specially a sharp edge tool for enlarging or tapering holes. Used for removal of the contents of the pulp canal and for widening and smoothing of the canal walls. It was manufactured by twisting the triangular blanks to produce the cutting edges. Each angle is of 60 degree approximately, which a knife edge is available, and the cross section is not excessively wide, so the instrument has a high degree of flexibility. Other is a K-type instrument with the ADS specification number of 28 and ISO standardization of 3630. It works by the compression and release destruction of the dentine surrounding the canal. It has a reaming motion, that is, if the constant file is in rotating and pushing motion, and causes less transportation than the filing motion, that is the reciprocation, or the if when used in the watch winding motion. K file stress deformation by clockwise and the counterclockwise twisting. The modification in it included the K flex file, or the different modification of tip design include the flex R file and C files. K flex file includes the rhomboidal or the diamond cross section, which increases its flexibility and the cutting efficiency, whereas the inflex R file, which is machined from the triangular cross section, has a modified safe end tip, that is non-cutting tip, reduction in the cutting angle, and has a balance force technique cuts during the anti-clockwise rotation motion. Later comes the golden medium file, which are the incremental or the intermediate ISO number files, making them a standard range instrument and prevents the number change from one to another. These files are stand out due to their greater flexibility, and there is a difference of 500th in a diameter. That is, a 12 number file, after a 12 number file, in between the 10 and the 15 there will be a 12 number file. In 20 and 25 there will be a 22 number file, and 27 and 32 so on, and the length of 21 mm. Next comes the headstrom file or the H file with the ADS specification number of 58. It is manufactured from the round stainless steel wire, machined to produce a spiral flutes over it. These spiral edges arrange around to allow a cutting only during the pulling strokes. The more positive rake angle is there and cuts the canal wall when the rotated clockwise. The file is relatively ineffective or when it is pushed or rotated in a counterclockwise motion. The modification in this file comes with the safety headstrom file, the high flex or the uni files or the S files. Safety headstrom or the safety edge file with a non-cutting side in order to prevent the ledging in the curved canal. High flex file or the cross section with the S shaped instead of the single helix teardrop shaped. The uni files, which are machined from the round stainless steel wire by cutting into two superficial grooves to produce the flutes in a double helix design. It has a similar appearance as that of the H file and less subject to fracture, but are less efficient and they are no longer marketed. The S file, it has a double helix cross section and is a variation in a uni file. It has a good cutting efficiency in either filing or the reaming action. Other instrument after the files, the other instruments include the micro openers and the micro debriders. Micro openers are to find the and enlarge the canal, which are of 17 mm K file types, which come with the number of 10, 15, and the taper of 4 and 6%. The micro debriders, these are the H file types which are hand operated and handle over it, characterized by the short shaft bend at an angle of 200 degree, available with the size of 20, 30, that is of only 2% taper, whereas micro openers were of 4 and 6% taper. The fluids clear the paste, the pulpal residue or the gutta percha and calcification. These instruments also allows the additional shaping of the canal. Other comes the Endodontic Explorer, which include the D5 Explorer or number 23-7 Explorer. The most important or purposeful explorer is the DG16 Endodontic probe, which determines the canal angulation as well as the orifice location. Other are the CK17 calcified used for the use in the calcified orifices. The JW17, which serves for the same purpose but are more thinner and stiffer than the DG16 and CK17 explorers. The DG16 Explorer was designed by David Green in 1951. It is a double-ended explorer, offers a two angle of 16 mm long tip with one end of 45-degree angle and other with the 75-degree angle, used to locate the orifices, estimating the canal angulation, removal of the small calcification and opening of the small canals. Different types are DG16 and DG16 by 23 Explorer. The endodontic excavator. These are the similar like the spoon excavator, but they have a long shank, have a much longer shank than the regular spoon excavator to better to reach the depth of the chamber, that is the floor. It is used to remove the carious material and excise the pulp tissue and the pulp stones. It is available in different shape and the slight variation in the angulations. Under the obturating instrument, we include the spreaders, which are the hand spreaders or the finger spreaders. The hand spreaders have a stainless steel and designed to facilitate the placement of accessory gutta percha point during the lateral compaction of the technique and not used routinely because of the excessive pressure, and there are the increased chances of vertical fracture due to the excessive pressure. The finger spreaders, which are shorter in length, allowing a greater degree of tactile and allow them to rotate freely around their axis. They are standardized and color coded with the correspond to the GP, gutta percha points. Next come the pluggers. Again the hand pluggers and the finger pluggers. Hand plugger have a diameter larger than the spreader and have a blunt end over it. It is used to compact the warm gutta percha vertically and laterally into the root canals. It also used to pack the MTA-like material or the calcium hydroxide material slightly to pack into the canal. The finger pluggers, which are used in a vertical direction, vertical compaction, and they are applied controlled pressure over the hand pluggers and also have a better tactile over the hand pluggers. Next is the instrument damage. There was a classification given by the Stokova of the instrument damage. The picture describes the type 1 damage is the bend of the instrument. The type 2 damage including the stretching or the straightening of the twisted contour. Type 3 damage of the peeling off of a metal at a blade angle. Type 4 is a partial or the clockwise twist of the instrument. Type 5 is the cracking along the longer axis. And type 6 fracture is a entire fracture of the instrument. Coming over to the conclusion, these are the different file design. There's cross section, material use, their cutting ability, and glide path formation. Its length, taper, and the techniques has been described. The most importantly, the K file with the square blank or the square cross section with the modification of triangular, made up of stainless steel material, having a good cutting ability, coming in the length of 21, 25 and 31 with a taper of 2% and using with the clockwise filing motion 45 degree or the watch winding motion. The K reamer which has been used with the cross section of the square blank and the material of stainless steel with the moderate level of cutting ability with the coming with the length of 21, 25, 31 and the taper of 2%. Technique used with a 90 degree clockwise reaming motion. The C file, which are the cutting file having a cutting tip, also made up of stainless steel material and has a good cutting ability, particularly used for the calcified canals. Next is the H file or the Hitchstrom file with the cross section of round or the circular cross section. Use of the made up of stainless steel, has a high cutting efficiency, having a slightly negative rake angle. We come with the length of 21, 25 and 31. Also has a taper of 2%, 4% and but only active while filing motion and without the rotation, and cut while removing the file. The brass broach, the flex SS file and the flex anti-K file. Thank you.